In this video, we'll be learning how to graph an equation in two variables. By the end of this video, you'll be able to draw the graph of an equation in two variables by making a table of values. In our last video, we learned that the graph of an equation is the collection of all points that satisfy the equation. So the question is, how do we find those points? What we can do is pick various x values. We'll take those x values, plug them into the equation, and then try to solve for the corresponding y value. This will guarantee that the x and y values together will satisfy the equation. To help us organize the pairs of x and y values that we find, we typically make a table of values. Let's look at how we would go about doing this for the equation 2x plus y equals 4. When we make a table of values, we'll make a table with two columns. One column for the x values and another column for the y values. Next, we'll pick various x values and put them in the x column. Typically, if you don't know what the graph looks like, you should pick x values around 0. So, for us, let's try picking the x values between -2 and 2. So I have -2, -1, 0, 1, and 2. For each x value, we'll want to find the corresponding y value that makes the equation true. So all we have to do is take that x value, plug it into the equation, and solve for y. So let's start with x equals -2. Plugging that into our equation 2x plus y equals 4 gives us 2 times -2 plus y equals 4. Simplifying this equation, we get -4 plus y equals 4. Then if we add 4 to both sides of this equation, we get y equals 8. This means that when x is -2, y has to be 8 in order for this equation to be satisfied, which means the point -2, 8 is a point that is on the graph of the equation 2x plus y equals 4. Now that we have one point, we'll just keep going down our list to find more points that will be on the graph of our equation. Our next x value is x equals -1. So we'll take -1, plug it into our equation to get 2 times -1 plus y equals 4. Again, we'll solve for y to find the corresponding y value. So simplifying the left-hand side, we get -2 plus y equals 4. Then adding 2 to both sides, we get y equals 6. So this tells us that the point -1, 6 is another point on the graph. For x equals 0, we have 2 times 0 plus y equals 4, which just tells us that y equals 4. So the point 0, 4 is on the graph of our equation. Next, we have x equals 1. So plugging in x equals 1, we have 2 times 1 plus y equals 4, which gives us 2 plus y equals 4. Subtracting 2 from both sides, we get y equals 2. So the point 1, 2 is a point on the graph. Our last x value is x equals 2, so we'll plug in x equals 2 into our equation to get 2 times 2 plus y equals 4, which simplifies to 4 plus y equals 4. Then subtracting 4 from both sides, we get y equals 0. So the point 2, 0 is a point on our graph. Now in general, there are infinitely many points that satisfy the equation. Here, we've only found 5. But what we can do is plot these 5 points on the xy plane and see if they form some sort of pattern. So on our coordinate plane here, we'll plot each of our points. First, we have the point -2, 8. Then we have -1, 6. Then 0, 4. Then 1, 2. And then 2, 0. Again, what I had mentioned earlier was that there are infinitely many points that satisfy the equation, which means there are infinitely many points that are on the graph of this equation. We've only plotted 5 of these points, but these points seem to fit a pattern. They all seem to lie on the same line. So what we're going to do is finish drawing this graph by connecting all of those points with a line. In general, we'll always start with a few points. We'll plot those points and see if those points fit any sort of pattern. If the points seem to form a certain shape, we'll connect all of those points to make that shape. Let's repeat this process with another example. In this example, we're asked to draw the graph of y equals x squared minus 2. Again, we'll start by making a table of values. So we make a table with two columns, one column for the x values and another column for the y values. We pick various x values. For example, we can look at the x values from -2 to +2. So we have -2, -1, 0, 1, and 2. We'll plug each of these x values into our equation to solve for the corresponding y value. So, for example, when x is -2, we plug that into the equation to get y equals -2 squared minus 2. Simplifying that equation, we get y equals -2 squared is 4, subtract 2 from that, we get 2. So this gives us our first point, -2, 2. We'll move on to the next x value, x equals -1. Plug that into our equation, we get y equals -1 squared minus 2. Simplifying that right-hand side, we get y equals +1 minus 2, so in the end we end up with -1. For x equals 0, we have y equals 0 squared minus 2. Simplifying that, we get y equals -2. For x equals 1, we have y equals 1 squared minus 2, which gives us y equals -1. And lastly, for x equals 2, we have y equals 2 squared minus 2. So that's 4 minus 2, or y equals 2. So our points here are -2, 2, -1, -1, 0, -2, 1, -1, and 2, 2. We'll take each of those points and plot them on our xy plane. So -2, 2 is over here, -1, -1, 0, -2, 1, -1, and 2, 2. This time, our points don't all fit on a straight line. It seems to have another pattern. The points seem to have a U shape, so we'll connect all of our points together in a way that fits that shape. The shape of this graph is called a parabola, and we'll learn more about this in the future. That's it for this video. In our next video, we'll learn about x and y intercepts. X and y intercepts are points that can be useful in helping us graph equations.